Hello, hello, hello. We are back with Chapter 8, Lesson 3, discussing line and angle relationships. So, when lines, segments, or rays intersect, they form angles. If the angles formed by two intersecting lines measure 90 degrees, the lines are called perpendicular lines. So perpendicular lines are angles formed by two intersecting lines that measure 90 degrees. So an example of perpendicular lines would be something like this. We have a line here, we have a line here. Let me put my arrows on there. They intersect, and you'll see a little box like that, which means it's 90 degrees. This would be an example of perpendicular lines. Okay? All right. That's what perpendicular lines look like. They also could be kind of tilted. Like it could be like this and look something like this. And then as long as it has that little mark there, you know that those are perpendicular. So it doesn't always have to be like, straight up and down and side to side. It can be tilted too and still be perpendicular lines. But you're looking for that little mark there. That little mark right there means it's a right angle, and it means it's 90 degrees, which means the lines are perpendicular. Okay? Some lines in the same plane do not intersect at all. These lines are called parallel lines. So parallel lines are lines that do not intersect at all. So lines in the same plane that do not intersect at all are called parallel lines. Now parallel lines would look something like this. Here's a line, here's another line, and they don't cross, okay? They just keep going on right next to each other, parallel. Now, whenever you deal with parallel lines, a lot of times they'll have little marks, and they're like a little mark like that. So if they have the same, it's kind of like tick marks, but different. So if they have those, you know that they're parallel. Another example of parallel lines could be something that looks like this. They could just be going straight up and straight down. Now, these lines are not parallel to those, so we wouldn't use one of those marks. If these are parallel to each other to show that they're parallel to each other, but they're not parallel to those ones, then we would use two marks like that on both of them. And so there's 1, 2. So you know that these two are parallel, but these have 2 marks and those have 1. So these aren't parallel to each other. Okay? The third term we're going to talk about are skew lines. Skew lines do not intersect, and yet they are also not parallel. They lie in different planes. So that's a big, big, big deal. They lie in different planes. Okay, so they don't intersect, they're not parallel, and they lie in different planes. So we're going to look at an example in a little bit, and I'll show you exactly what skew lines are. Okay? Reading math, the symbol that looks like this means is parallel to. So we could have something like this. Just for example, if I had two lines, I'll have it like this, and this line here, and let's say I put some points on here, and this is A, and that's B, and this is C, and that's D, and I have a little mark showing that they're parallel. I could say this. I could say that line AB and line CD are parallel to each other. And that's how I'd say line AB is parallel to line CD. Okay? And the symbol that looks like this, like an upside down T, means is perpendicular to. So let's say I had a figure like this, and then it went like that. Okay, and we have a little mark there which shows that it's perpendicular 90 degrees. And let's go ahead and label these. We're going to call this X, this Y, and this W and Z. Okay? So then what we could say is we could say line WZ and line XY are perpendicular to each other. So that means that line WZ is perpendicular to line XY. All right, just a little bit of terminology for you, little symbols. So let's go on and look at what an example would look like. Okay, so example 1A, we're going to identify parallel, perpendicular, and skew lines. So we're going to tell whether the lines appear parallel, perpendicular, or skew. So the lines that we're going to be looking at first are lines UV. So where's UV? UV would be right here. This is UV. And line YV. YV is right here. YV. Now, to me, these lines look as if they are perpendicular. There's not a little sign there, but for this exercise, this line is here, this line is there. It looks like it meets at a 90-degree angle. So we're going to say that line UV is perpendicular to line YV. And that would be our answer right there. Okay? Perfect. Okay, let's go on to example 1B. We're going to do the same thing, except now we're looking at these two different lines. We are looking at XU and WZ. WZ right here. All right. Now these lines, you can tell they're definitely not parallel. They definitely will not intersect because this line is going up and down and this one's going side to side. They are not in the same plane at all. So this would be an example of what skew lines would look like. So we would just say these lines are skew. There is no fancy symbol for skew lines. These are skew lines. We'll just say lines. Skew lines. That's what these are. Skew lines. Okay? All right. Let's go ahead and look at the next example, which would be example 1C. Okay, 1C, we're doing the same thing. Now we're looking at lines XY. So XY would be right here, XY, and WZ, which would be right here. Now these lines definitely look as if they're parallel, so we can say line XY and a line WZ are parallel. We can use the parallel symbol like that. Okay? So that shows you what perpendicular lines are, skew lines, and parallel lines look like. So now it is your turn to, did you see that? Did that show in the picture? These are perpendicular, skew lines, and parallel. Okay, now it is your turn to check it out. So I want you to go ahead, try, check it out, examples 1A, 1B, and 1C, okay? So go ahead and pause your device right now. Try both of example 1A, 1B, 1C. When you get done, press play and we'll see how you did. All right, see you in a bit. All right, we are back. Let's go ahead and see whether these lines appear to be parallel, perpendicular, or skew. Okay, the first one is WX. WX is right here. WX. And XU. XU is right here. Okay, and those lines appear to be perpendicular. So we're going to say line WX is perpendicular to line XU. Okay, so if you got that one right, great job. Okay, let's go ahead and check out example 1B. Now we're looking at WX again. WX and UV here. Well, these lines definitely are not perpendicular. They're definitely not parallel, and they are in different planes. So they will never intersect. So we're going to say that these are, this is an example of skew lines. So if you got that one right, wonderful. Okay, on to check it out, example 1C. So now, again, we're looking at WX and ZY, which is over here. I think it's pretty clear to say that those lines are parallel. So we're going to write WX is parallel to ZY. So if you got all those right, wonderful job, and you wrote the symbols and everything, you're doing awesome and you're on the right track. Okay, let's keep moving forward. The next thing we're going to talk about is a little bit more terminology. We're going to discuss adjacent angles. Adjacent angles have a common vertex and a common side. Okay, so let's look here at angles 2 and angles 3. Angles 2 and angles 3, they share a vertex. It's right here. So that's the first part. They have a common vertex. And they also have a common side. If you see, angle 2 and angle 3 share this side right here. Okay? So they have a common vertex and a common side, but no common interior points. But no common interior points. What that means is that any point that I mark, here's angle 3, right? So this would be an interior point. It would be a point inside angle 3. Now, is this point inside angle 2 over here? No, it's not. Okay? What about this point over here if I made a point in angle 2? Is this point in angle 3? No, it's not. Actually, any point I put in here, whether it's here, 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 or here, none of these points are inside angle 2, okay? And any other points I put over here in angle 2, none of these interior points are in angle 3. So they have no common interior points. Any point inside angle 2 is only inside angle 2. It's not inside angle 3. And any point inside angle 3 is only inside angle 3 and not angle 2. So this right here is an example of adjacent angles. Angle 2, right here, this angle, I'm going to say this is angle 2 is going to be in yellow here, is adjacent to angle 3, which is going to be orange. These two angles are considered adjacent angles. What does it say? Angles 2 and 3 in the diagram are adjacent. Adjacent angles formed by two intersecting lines are supplementary. So you see how these two lines are intersecting and they form these two adjacent angles? What that means is these two angles are supplementary, which we could totally write an equation. We could say the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Okay? These two angles are supplementary, which means they add up to 180 degrees. Perfect. Let's go ahead and talk about the next term. The next one, this one's never going to go away. You have to memorize this one. I'm telling you, it will make your life easier. Okay? This one is dealing with vertical angles. Vertical angles, vertical angles, vertical angles, vertical angles. Do not forget about vertical angles. It will come up on tests and all these types of things. And you have to know this because it's really super easy, okay? Vertical angles are the opposite angles formed by two intersecting lines. So if you look here, we have this line and we have this line. These are two intersecting lines. Now the angles formed that are opposite. So right here, angle 2 is opposite from angle 4. These are called vertical angles. When you have intersecting lines, the two angles that are directly opposite from each other are called vertical angles. Now, the really super cool thing about vertical angles is that they're congruent to each other. So if you have vertical angles, two angles that are opposite from each other, they are exactly the same measure, okay? So angle 2 is congruent to angle 4. And you can kind of see that because they have these arcs and these little tick things, and there's 1, 2, and 1, 2, which means they're congruent. So we can actually say that angle 2 is congruent to angle 4 because they're vertical angles. And you can see that because of these two tick marks right here. There's this arc for the angle and the two tick marks here, the arc and the two tick marks there. That means that they are vertical angles and they are congruent. But oh wait, there's more. You don't just have one set of opposite angles. There's another set of opposite angles right here. Angle 1 and angle 3. They are opposite angles as well. And guess what? They're also congruent. And you can tell that by this tick mark right there. There's one tick mark right there and right there, which means we can write and say that angle 1 is congruent to angle 3. Isn't that cool? I love vertical angles, okay? So this states that angle 1 and angle 3 in the diagram, angle 1 and 3 are vertical angles. Vertical angles have the same measure, so they are congruent. So let's say, hey, this angle right here is 30 degrees. I'm just throwing something out there. If angle 1's 30 degrees, guess what? No, angle 1 is 30 degrees. Guess what angle 3 is? It's equal to 30 degrees too, because they're congruent. They are the same. Okay? And we know that these are supplementary, right? There's intersecting lines. That means 1 and 2 are supplementary. That means they add up to be 180 degrees. So if this is 30, that means this has to be 150 degrees because 150 plus 30 is 180. And if this is 150, guess what this is? It's 150 degrees too because of vertical angles. They're the same measure. Okay? So very, 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 very cool. Okay, let's see here. reading math. It says angles with the same number of tick marks are congruent. So if you see here, this is an angle that has 1, 2 tick marks, and this is another one that has 2 tick marks. So because they both have 2 tick marks, they're congruent angles. The tick marks are placed in the arcs drawn inside the angles. All right? Okay, just a little fun stuff for you. Okie dokers. Okay, let's move on to the next thing. The next thing here, I'm going to have to zoom out. Okay, more terminology. A transversal is a line that intersects 2 or more lines. Okay, so a transversal, 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 transversal. A transversal is a line that intersects 2 or more lines. Okay, so let's say I have 2 lines like this. Okay, I got 2 lines. A transversal, are these lines intersecting? No, they're not. But if I draw a line like this down, do you see how this pink line intersects this green line and this other green line? I should put little line things on there. That means this pink line is called a transversal. Okay? That is a transversal. It is a line that intersects 2 or more lines. So it intersects this green line here. That's an intersection. And it also intersects this other green line here. It intersects 2 lines, so it's called a transversal. This says that transversal to parallel lines form special angle pairs. Transversals to parallel lines form special angle pairs. And there's actually 3 angle pairs that we're going to talk about. Okay? The first are alternate interior angles. Okay? So what we have here is it's only if the lines are parallel. That's super, super important. The lines have to be parallel. Okay? They have to be parallel. So transversals to parallel lines form special angle pairs, and there's 3 of them. This would be 1, alternate interior angles, 2, alternate exterior angles, and 3, corresponding angles. So let's go ahead and look at them. Okay, first, what we're going to say are these lines right here, they are parallel. So I'm going to go ahead and put a little mark like that showing that they're parallel. Now, what is this line? This line intersects those 2 parallel lines. Now, this only works if the lines are parallel. They have to be parallel. Okay, so they have to be parallel lines. So you can only apply these 3 things, special angle pairs, if you're dealing with parallel lines and a transversal intersecting parallel lines. Okay, so what you have to understand is that whenever you have this parallel lines and you have a transversal, you have to tell the difference between interior angles and exterior angles. Okay, first let's just talk about angles. Okay, so I'm gonna do another example over here. So let's say I have 2 lines here, and I have my transversal, which is gonna come like this. Okay, what you have to understand is what just happened, and we're going to call these parallel lines. Okay, well, I'll do the parallel mark right here. What just happened when this transversal intersected those 2 parallel lines is it created a lot of angles. This is angle 1, that's angle 2, this is angle 3, this is angle 4, this is angle 5, this is angle 6, angle 7, and angle 8. When that transversal intersected those 2 parallel lines or 2 lines, it just created 8 angles. That's a lot of angles. 1, 2, 3, 4, 5, 6, 7, 8. Now, some of those angles are interior and some of them are exterior angles. So the interior angles are the angles that are inside the 2 parallel lines. So inside the 2 parallel lines, these are called interior angles. Do you see that? Okay, so inside would be interior angles. And then outside of the parallel lines, which would be outside, if this is inside the parallel lines, outside the parallel lines would be out here. This is outside the parallel lines. So 1, 2, 7, and 8. Those are called exterior angles. So we have exterior angles out here. And we have exterior angles out here. So 1, 2, 7, and 8, those are exterior angles, where interior angles are 3, 4, 5, and 6. Okay? So let's go ahead and talk about alternate interior angles. So it's talking about interior angles, which means it's only talking about the angles inside the parallel lines. They're inside the parallel lines. Those are interior angles. But it says alternate. Alternate. Alternate means on alternate sides of the transversal here. So if this is the transversal, alternate would be, if this is on one side, the alternate side would be over here, right? Or if we have an angle here, the alternate side would be here, okay? So alternate interior angles would be this right here. This angle here, alternate interior. So it has to be inside the alternate interior angle. This is an interior angle. The other alternate would be on the other side of the transversal, would be right here. These two angles, believe it or not, are congruent. These are alternate interior angles. So let's say this angle, we know these lines are parallel. This is 60 degrees. That means because of alternate interior angles, that this angle is also 60 degrees. They're congruent. They are the same. But that's not it. There's one other pair. This one right here. This angle is also an interior angle. And guess what its alternate interior angle is? It would be this one right here. This is the only one that's inside the parallel lines, and it's on alternate sides of the transversal. These are alternate interior angles, and they are also the same. Now, we know if this is 60 degrees, and these two lines are intersecting, these two angles are supplementary, which means they add up to 180 degrees. So if this is 60 degrees, we know that this right here is actually 120 degrees, which means that its alternate interior angle is also 120 degrees. They are the same. The alternate interior angles are congruent, and these alternate interior angles are congruent as well. Okay, that is alternate interior angles. Let's go ahead and move on to alternate exterior angles. So now we're not talking about interior angles, the things inside the parallel lines. Let's go ahead and say that these lines are parallel. I'll use 2. We're talking about alternate exterior. So we're talking about the angles that are outside of the parallel lines here. Those are exterior angles, but they're alternate. They're on alternate sides of this transversal. So if we have one angle right here, the alternate exterior angle is going to be over here on the other side of the transversal. And guess what? these angles are the same as well. So if this angle is 120 degrees, guess what this angle is? It's 120 degrees. They're the same measure because they're alternate exterior angles. And if we know that this one is 120, because we know that these intersecting lines form they're supplementary, we know that this angle right here on this side is going to equal 60 degrees, which means its alternate exterior angle, which would be over here, is also going to be 60 degrees. This is 60 degrees and this is 60 degrees. They are the same. They are congruent because of the alternate exterior angles. So here we have alternate interior angles, which are congruent. Here we have alternate exterior. They're on the outside of the parallel lines, and they're alternate sides of the transversal, and they are congruent. The third we're going to talk about are corresponding angles. Corresponding angles are angles that are actually on the same side of the transversal. One is interior and one is exterior. Okay? So if I have this angle right here, they have to be on the same side of the transversal. Okay? So, and one is interior, then this one has to be exterior right there. Those are corresponding angles. So if this one is 60 degrees, guess what this one is? They're the same. This one's 60 degrees. Let's look at another one. Let's look at this one right here, this angle. If this one's interior, its corresponding angle is going to be on the same side of the transversal, but this is interior. This one's going to be exterior. These are the same measure. We can actually figure out what it is because of these intersecting lines, and we know that these two adjacent angles, because they're adjacent, they're supplementary, which means they add up to 180 degrees. So if this is 60, we automatically know that this one's going to be 120 degrees, which means that its corresponding angle is also going to be 120 degrees. Right there. Do you see that? Very cool. But look, it's not just on that side. We have a different set over here. Okay? If we have this interior angle here, its corresponding angle, if this is interior, is going to be on the same side of the transversal. It's going to be on the same side of the transversal, but this is interior. This one's going to be exterior. These are the same. These are corresponding angles. And the cool thing about it is if we know this one right here is 120 and they're intersecting because of vertical angles, this is also going to be 120. Right? Which means that its corresponding angles are the same. So this is 120. Which is super cool because these are also adjacent angles, which means 120 plus 60 is 180. So they're supplementary. And the same is true here. These two angles are adjacent, which means 120 is plus 60 is 180. So these are also supplementary. There's one last set of corresponding angles. And those would be the angles right here. If this is the interior one, it's on the same side of the transversal, except this one's exterior. So if you have one interior, one exterior. All right? And so these are the same. And because of vertical angles, this is 60 degrees. We know this is 60 degrees. And because of corresponding angles, if this is 60, this is also 60. So there you go. Those are all the corresponding angles. This is one set of corresponding angles. This is another set. The orange is a set, and the blue is a set. So let's go ahead and read this. Properties of transversals to parallel lines. The key is that they're parallel. Oh, I forgot to say. These are parallel lines. I'm going to say there's 3 marks. 1, 2, 3. This is only true with parallel lines. You have alternate interior angles, alternate exterior angles, and corresponding angles. So what it says, if 2 parallel lines are intersected by a transversal, corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. So let's go ahead and look at a couple of different examples of how this works. Our first is example 2A, and I'm going to go ahead and zoom in a little bit. So example 2A says, using angle relationships to find angle measures. So what it states is line N is parallel to line P. Well, automatically, when you know that those 2 lines are parallel, we know that that opens the door to, you guessed it, alternate interior angles, alternate exterior angles, and corresponding angles. Okay, back to the problem. So we know that line P is parallel to line N. So I'm going to make a little parallel mark there, showing those 2 lines are parallel. And then what do we have? We have a transversal right there, okay? What we want to do is find the measure of angle 2. So what is the measure of angle 2? Which would be right here. This is angle 2. What's the measure of it? What is the measure of angle 2? Well, what I see right off the bat are vertical angles. This right here, 130 degrees, is the vertical angle to angle 2. So that means that they're congruent. So that means angle 2, the measure of angle 2 equals 130 degrees by vertical angles. Okay? Let's go ahead and look at example 2B. Example 2B says, again, that line N is parallel to line P. So I'm going to go ahead and make my little parallel marks. We need to find the measure of angle 3. The measure of angle 3. So angle 3 is right here. Now, because these lines are parallel, we know that unlocks the door to alternate interior angles, alternate exterior angles, and corresponding angles. So let's go ahead and look at this. How would we determine what the measure of angle 3 is? Well, we have 130 here and we have 50. What do you notice about 3 and 50? These lines are parallel and they're on the same side of this transversal. One is interior, one is exterior. So you know what that means? They're corresponding angles, which means they're congruent. That means that the measure of angle 3 is equal to 50 degrees because of corresponding angles. All right, pretty cool. Let's go on to the next example. Example 2C. Okay, so again, we have line N is parallel to line P. So I'm going to go ahead and make that little parallel mark. Except this time, we're trying to find the angle measure of angle 4. The measure of angle 4. The measure of angle 4 is right here. Now remember, these lines are parallel, which opens the door to alternate interior angles, alternate exterior angles, and the corresponding angles. So let's go back to our problem here. What I see is that 4 is an interior angle. And I also see that 130 is an interior angle. And they're alternate. They're on alternate sides of the transversal. So this is an example of alternate interior angles. So if this angle is 130, that means the measure of angle 4 is also 130. So that means that the measure of angle 4 is equal to 130 degrees because of alternate interior angles. All right, cool. Okay, we're going to move on to check it out, example 2A. This is your turn, ladies and gentlemen, to check it out. I want you to go ahead and try to figure out problem 2A. So I want you to go ahead and pause your device right now. When you get done, press play and we'll talk about it. All right, we are back. The problem states that line N is parallel to line P. Okay, so I'm going to mark my little parallel marks. Line N is parallel to line P. Okay, it wants us to find the measure of the angle. We're finding the measure of angle 3. So the measure of angle 3 is right here. Right there. And what I see is directly across from this is 45 degrees. Those are vertical angles. That means they're congruent. So if you put the measure of angle 3 is equal to 45 degrees because of vertical angles, you are doing awesome, amazing, wonderful. I'm so proud of you. Okay, let's go ahead and move on to check it out, 2B. All right, 2B right here. Okay, we know that line N is parallel to line P, so I'm going to go ahead and mark my little parallel marks here. And because they're parallel, we know that we can, this unlocks the door to alternate interior angles, alternate exterior angles, and also corresponding angles. Okay. Okay, zoom in, zoom in, zoom in. Okay, we're looking at angle 6. Angle 6 is right here. Angle 6 is right here. We're trying to determine the measure of angle 6. Do you see anything? Do you see anything? Do you see it? Directly across from angle 6 is 135 degrees. These are opposite angles, which means they're vertical angles, which means they're congruent because of vertical angles. So that means that the measure of angle 6 is equal to 135 degrees. All right, on to the last one. Check it out, 2C. This is the one I want you to do on your own. So go ahead and pause your device. When you get done, press play, and we'll talk about it. Okay, we are back. We have that line N is parallel to line P. So I'm going to go ahead and make my little parallel marks here. I'll make 2 this time. Okay, we're trying to determine what angle 4 is. So here's angle 4 right here. And angle 4 is right here. Okay, angle 4 is an interior angle. And I see 135 is also an interior angle, and it's on alternate sides of this transversal. So these are alternate interior angles, which means they're congruent. All right, so measure of angle 4 is equal to 135 degrees because of the alternate interior angles. So if you got that one right, yokorikimashita, you did a great job, and we will see you next time. Bye-bye.